Hello, and welcome to this edition of the Pulse on Power Show. I'm Ed Merkel, and we are pleased to present to you this series of videos designed to demonstrate the key features that you should be considering when buying a power supply. Today's video will focus on output current reserves, a feature of the PULS power supply that can deliver higher than rated current with no change in the output voltage. PULS large current reserves can prevent oversizing of power supplies because our design can handle a large inrush of current common in the startup of various demanding loads. The PULS Dimension family offers two types of output power managers. The C series offers 20% current reserves, which can operate continuously at an operating temperature of less than 45 degrees C. The Q series has a smart firmware controlled overload design called bonus power, which can deliver up to 50% extra current with no change in the output voltage for up to 4 seconds. This demonstration will illustrate how a PULS Dimension C series 5 amp power supply performs against two other competitive 5 amp power supplies. But check out our bonus power video to see how the Q series operates in peak and overload conditions. This demo will connect each of these 5 amp 24 volt supplies individually using this selector switch to a variable 10 amp resistive load. The voltmeter and ammeter will show how the output of each supply performs as the current increases. Each of these switches will add 1 amp load to the power supply. Let's start out first by demonstrating the PULS supply. At no load, the output voltage is set at 24 volts DC. If I flip 5 of the switches, the ammeter shows that the unit is delivering 5 amps, the rated current of the device. The C series offers 20% current reserves, so as I flip another switch, the output load increases to 6 amps and the output voltage remains at 24 volts. So the power being delivered is actually 144 watts, which help starts difficult loads. The guaranteed current reserve for the C series is 20%, but let's see what happens when we continue to increase the output current. If I add another amp, the meter shows that I am drawing 7 amps from the supply and my output voltage remains at 24 volts. When I increase the load to 8 amps, the ammeter shows that my unit is starting to current limit as a full 8 amps is not being delivered from the supply. The output voltage has only decreased slightly, so the supply is delivering almost 160% of rated current with only a slight change in the output voltage. When the load is increased to 9 amps, the power supply is only delivering slightly higher than 8 amps, and the output voltage has dropped to around 21.5 volts DC, but the DC OK LED is still illuminated. As the load current is increased to 10 amps, the supply does not deliver much more current, and the voltage has dropped to around 20 volts DC. The DC OK LED is still on, but very dim, indicating that the DC is almost out of range. If the output of the supply is running at rated current, but the load becomes shorted, the power supply delivers a current higher than 10 amps, and the output voltage drops to about 1 volt DC. These are values supported in the data sheet. However, once the fault is cleared, the power supply automatically recovers. Let's repeat the same steps on this first competitive 120 watt supply. At no load, this unit is also set at 24 volts DC. As expected, the power supply has no difficulty of delivering the rated current of 5 amps with no change in the output voltage. At 6 amps, the power supply has no change in the output voltage. However, at 7 amps, the output current limits to around 6 amps and the output voltage drops to around 20.5 volts. When the load is increased to 8 amps, the unit remains current limited around 6 amps, the output voltage drops to 18 volts DC, and the DC low LED turns on. At 9 amps load, the voltage drops to 16 volts, and at 10 amps, the output voltage falls to a low value of 14.5 volts. When a short circuit is introduced when the unit is running at nominal current, the unit can deliver only around 7 amps and the output voltage falls to about 1/2 volt. This supply also recovers after the fault is removed. Performing the same test on the second competitive 120 watt supply, the output results are predictable at no load and when running at 5 amps. However, this unit gives an alarm when operating at 5 amps. According to the manufacturer's data sheet, the LED pattern indicates a high load. At 4 amps, the LED indicates that all is well, but at 5 amps, the alarm LED is on. This condition can be misleading to an operator or to maintenance personnel who might suspect that something is wrong when in fact the unit is delivering the rated current. This supply can also deliver 6 amps with no change in the output voltage. When the load is increased to 7 amps, the unit current limits to around 6 amps and the output voltage drops to about 19.5 volts. At 8 amps, the unit is still only delivering around 6 amps and the voltage drops to 17 volts. At 9 amps, the supply remains at 6 amps and the voltage is around 15.5 volts. When the load is increased to 10 amps, the voltage drops to 14 volts and the LED pattern is the same as the condition at 5 amps, but the voltage is too low to operate most 24 volt loads. When the short circuit condition is applied, the unit delivers only around 8.5 amps, the voltage is at 0.5 volt, and the LED pattern indicates an overload. Self-recovery does occur when the fault is cleared. It is interesting to wonder why when the output voltage drops below 20 volts with a 7 amp load, an overload condition is not indicated. Although both competitive models can produce 20% current reserve, their performance radically drops off once the current goes above 6 amps. So independent of what the LEDs are indicating above 6 amps, the output voltage drops to a level where most loads will not operate. The PULS unit not only delivers a higher current limit, but the output voltage remains at or above 20 volts, allowing most loads to function. The higher voltage and current will allow the PULS power supply to deliver the necessary power when starting a demanding load, without oversizing the power supply. The other units with lower current and voltage will just simply not have enough power to sustain the load. Thank you for joining us. If you have additional questions, please call us or refer to our website where we have additional information on our products and applications. All of us at PULS, thank you for joining us today, and we look forward to seeing you on our next edition of Pulse on Power.